The learning objectives for today's lesson is to be able to evaluate expressions involving the natural base and natural logarithm, and solve exponential equations using natural logarithms. Look at natural base exponential functions. So what are natural base exponential functions? Well, they're functions of this form, where f of x is equal to e to the power of x. So you still have a variable x in the exponent, but whenever you see a base e, this is the natural base. So what is e? E is just an irrational number, okay, and it's approximately equal to this number here, and it's named after the Swiss mathematician Leonhard Euler, and this is a picture of him there, which is often why we call it Euler's number. Now this base is the most commonly used base in real-world applications. So you should notice that e is greater than 1. So the graph of e to the power of x is very similar to an exponential growth function. So it would look like this, going through the y-intercept 0, 1. Now the inverse of a natural base exponential function is called the natural logarithm. So over here we have the graph of an exponential function which has a natural base e. Now we can see this is a continuous graph and it's a one-to-one function, so therefore it has an inverse function. So we can reflect this in the line y equals x to give us this inverse function here, which we call the natural logarithm. Now this logarithm is often written as log base e of x, or we could pronounce it as the natural log of x. However, it's more often abbreviated as ln x. We still pronounce this as the natural log of x. For example 1, we want to write the following exponential equation in logarithmic form. So we have e to the power of x equals 8. This is our exponential equation, and we want to write it in logarithmic form. Now, before we do that, let's just recall this exponential equation here. So we have the base a and the exponent y, and we would rewrite this in logarithmic form like so. So we have the base a, which is written over here, and the exponent y, which is written over here on the right hand side. So applying this to our exponential equation, we get the following. So we write down log base e of 8 equals x. So you can see that the base e corresponds to the base e here, and the exponent x here is written on the right hand side. Now remember, we can abbreviate this further. So log base e of x can be written like this. So we can replace log base e with ln and abbreviate it as the natural log of 8 equals x.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom, where we cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. The first session is always free. So if you are interested in a free lesson, click the link in the description below. To book a lesson, you can always send us a direct message on Instagram at Mr. Mathematics. Okay, with that said, let's get back to our lesson.
Now, for example 2, we want to write the following expression as a single logarithm. So we have this expression here, which has two logarithmic terms. So we have the natural log of 10 and the natural log of 8. And we want to write this expression as a single logarithm. So the first thing we'll do is, the first term, we can use the power property of logarithms to write the 3 here as an exponent of 10. Okay? And now, because they both these terms, or both these logarithms, have the same natural base, we can apply the quotient property of logarithms and rewrite a simplified version over here. So we've taken the natural log of 10 to the power of 3 divided by 8. Okay, and this, what we have over here, can be simplified to 125. Now you should recall 125 is a power of 5, so 5 cubed equals 125. And we'll replace what we have here with 5 cubed to give us the following. Okay, and then we can apply the power property of logarithms, okay, and take this exponent here and write it at the front. So we have 3 multiplied by the natural log of 5 as our final answer. Now for example 3, we want to solve this equation and then round the answer to the nearest 10,000th. So if this is our original equation, our first strategy is to isolate the power term. Okay, so we'll begin by adding 5 to both sides to give us the following. And we can undo this 4 by dividing each side by 4 to give us the following. And now we've isolated the power term. So we can see this is a natural base e. So we can take the natural logarithm of both sides by applying the property of equality for logarithms to give us the following. And on the left-hand side, you should recall when we take the natural log of the natural base e to the power of x, we'll be left with x. So on the left-hand side here, the natural log of the natural base e to the power of negative 2x, on the left-hand side we will be simply left with negative 2x. Okay, now we want to isolate the x, so we'll divide each side by negative 2 to give us the following, and we can input this into the calculator, okay, and that will give us the following answer. So we have x is approximately equal to negative 0.3466, which has been rounded to the nearest 10,000th. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following.